Bonjour tout le monde. Hello everyone. Welcome to this second to last lecture of the series Renewed Histories, or Nouvelles Histoires, which I am co-organizing with my colleagues Fanny Lopez and Frédéric Moquet. Today, we are extremely pleased to welcome Jiat-Hwee Chang. Jiat-Hwee is an associate professor and the deputy head of the Department of Architecture at the National University of Singapore. And before becoming a scholar, Jiat-Hwee was trained as an architect at the same National University of Singapore. He also holds a PhD in architecture from the University of California, Berkeley. His PhD dissertation was published in 2016 in the form of the book A Genealogy of Tropical Architecture, Colonial Networks, Nature, and Technoscience. In this influential book, very important for my own research as well, Jiat-Hwee traces the origins of the so-called tropical architecture, more or less an equivalent of the bioclimatic architecture as it is known in the West. In short, Jiat-Hwee brilliantly argues that architecture's adaptation to the climate and resources of the tropics is entangled with the colonial power of the British Empire in Southeast Asia. The colonizers developed climatic devices, technical knowledge, and building types to try to adapt to this environment while controlling the local populations and resources. And the present discussion on tropical and climatic architecture inherits from this past. This book led Jiat-Hwee to lecture in many institutions around the world and to be a fellow at the Canadian Center for Architecture in Montreal and the Rachel Carson Center for Environment and Society in Munich, among others. Since then, Jiat-Hwee has extended his research to other topics, notably the heritage of modern architecture in Southeast Asia, as well as the history of air conditioning across Asia and the Middle East. So before I leave you the floor, Jiat-Hwee, for your lecture, I want to make just a brief announcement about the last lecture of the series, the one I will give. For organizational reasons, it is postponed of a week, so it will be not on May the 10th, but on May the 17th. Je vais le dire en français pour pas qu'il y ait de confusion, d'ambiguïté. La dernière conférence, celle que je dois donner, n'aura pas lieu le mardi 10 mai comme prévu initialement, mais est reportée d'une semaine. Elle aura lieu le mardi 17 mai à 13h15. So now the floor is yours, Jiat-Hwee, and as always, we will have some time for questions and answers at the end, preferably in English or in French, and I will try to translate them.
Thank you so much, Paul, for having me. So maybe I can start by sharing screen. So I hope all of you can see my screen.
Yes.
Yeah. Okay, wonderful. So thanks again, Paul, for your very generous introduction. What I'm going to share is really a work in progress. So as Paul mentioned previously, I look at tropical architecture from the mid-19th century roughly to the mid-20th century. This work in a way follows from that. So one can say is post-tropical architecture. So if the previous one is about using a building to mediate the environment, this is more about using technology to mediate the environment. So this research project is very much about air conditioning. It is a work that has been that is in progress and has been in progress for a very long time. I hope you will forgive the lack of polish in some parts because this is really not something that I've already completed. So I'm just sharing a work that is still ongoing. And of course, I will appreciate any criticism and feedback and question. So without further ado, let me start. I should start by signposting this lecture. It has 4 parts. I start by introducing thermal governance. Then I move on to examine the 2 sides of Singapore and Doha. I conclude briefly by examining how thermal governance has been recalibrated in the Anthropocene. So let's start with the first part. As temperature rises and heat waves become more frequent and intense due to the climate crisis, cooling technologies, particularly air conditioning, has received much attention from global environmental NGOs and international media. International Energy Agency 2018 report, The Future of Cooling, for instance, highlights the threat posed by the quote, rampant growth in demand for space cooling, with far-reaching implications for emissions, energy security, and electricity costs, end quote, and cause the threat a looming cold crunch. It warns that if unchecked, the global energy demands of air conditioning will more than triple by 2050, which will strain energy infrastructure and exacerbate climate change. Most of this escalation in global energy demands for air conditioning will take place in the global south due to the convergence of three types of trends: climatic, economic, and demographic. Climatically, the developing countries in the tropics and subtropics are projected to be more severely affected by the climate crisis and will experience comparatively greater increases in temperature, leading to a surge in demand for cooling. Economically, these same countries are projected to experience rapid growth, enabling more of their populations to afford air conditioning. And finally, demographically, these countries are expected to have the fastest rate of population growth. In 2018, another report titled Chilling Prospects, Providing Sustainable Cooling for All was released by an NGO, Sustainable Energy for All. Taking a broad understanding of cooling, including both space cooling and cold supply chain, the CEO of Sustainable Energy for All, Rachel Kite, said, I quote, "In a world facing continuously rising temperature, access to cooling is not a luxury. It is essential for everyday life," end quote. Given the importance of cooling, the report urges governments around the world to close the cooling access gap for the estimated 1.1 billion population, mostly in the global south, who are currently unserved or underserved by space cooling and cold supply chain, for them to meet United Nations Sustainable Development Goals. From the two reports, the key challenge seems to be, how do we cool the world's population in an equitable manner without further warming the climate? In a way, the Global Cooling Prize was a competition launched in 2018, seeking a technological fix to that challenge, organized by Rocky Mountain Institute and supported by the Indian government. The prize is a multi-stage competition with a total prize money of $3 million US, in search of an affordable and radically efficient room air conditioner, designed primarily for the hot climates of emerging economies. The competition attracted 139 entries from a combination of established multinational corporations and startups in 31 countries. The two winning entries awarded in 2021 involved two of the world's largest air conditioning manufacturers, the Indian branch of the Japanese headquarter Daikin and GLI from China. The belief that the panacea for all kinds of social and environmental problems linked to air conditioning could be found in a technological solution is typical of the general technocentric approach adopted by policymakers. But this technocentric approach disaggregates and isolates the technological from the social, political, and material cultural entanglements, and reduces air conditioning to a technical problem to be solved by engineers and building technologies. Instead of taking a disaggregative and reductive approach to air conditioning, I draw from architecture history and theory, urban studies, and STS, or science, technology, and society, to examine the various interdependencies and entanglements between air conditioning, politics, society, and the environment that are hinted at by the first two reports. In this lecture, I narrate the social, spatial histories and technopolitics of how the two cities of Singapore and Doha became heavily dependent on air conditioning and are attempting to transit to a low-carbon future. Singapore and Doha are chosen because I want to turn our attention from the much researched North American examples to explore cities located in the hot tropical and desert regions of the global south, where demands for air conditioning are projected to grow exponentially in the near future. Although Singapore and Doha might be seen as non-typical of the region due to their economic affluence and quote-unquote addiction to air conditioning, they are not exceptional. The way certain segments of Singapore's population move in the air-conditioned continuum between their mechanically cool homes, offices, and shopping malls in their air-conditioned cars is not very different from the manner middle-class population in other Southeast Asian capitals like Bangkok, Jakarta, and Manila are always encased in the social environmental bubble of air conditioning. Doha is even more similar to the other cities in the Gulf Cooperation Council or GCC countries, such as Kuwait City, Dubai, and Abu Dhabi, especially in terms of their social environmental norms and dependency on fossil fuels. The cheap hydrocarbons and the heavily subsidized electricity in these sprawling desert cities meant that the central business districts are filled primarily with climate inappropriate and energy profligate buildings that one commentator characterized as glass refrigerators in the desert, while the suburbs are populated with luxurious and overly cool villas. Neither Singapore or Doha is, however, a monolithic social environmental entity. While large air-conditioned buildings, including those linked by district cooling systems, dominate the city center in Singapore, 80% of the population in Singapore live in public housing that were designed to be passively cool, but also incorporated air conditioning subsequently. This housing were connected by networks of naturally ventilated void decks and covered walkways to the public transport infrastructure. Although buses and trains are air-conditioned, many of the shelters that serve as nodal points for the infrastructure are open air, with high-volume, low-speed fans augmenting natural ventilation to relieve the humid heat. In other words, the thermoscape of Singapore is a hybrid amalgam of various modes of cooling that defies the binary of passive versus active or natural versus artificial. Such thermal diversity also exists in Doha, though to a smaller extent. Buildings like the surviving courtyard houses from the mid-20th century, the Qatar University buildings that were completed in 1985, and even the recently reconstructed Souq Waqif utilizes climatic appropriate design strategies to modulate the desert heat amidst the predominantly air-conditioned thermoscape. In fact, both countries are characterized by not just heterogeneities, but also glaring inequalities that juxtapose what media studies scholar Nico Staroselsky calls thermal privilege with thermal violence. Qatar in particularly is known for its migrant workers falling ill and even dying from overexposure to heat. Qatar's high-profile involvement in the hosting of the 2022 FIFA World Cup has subjected it to intense international scrutiny and put the working and living conditions of its migrant workers involved in the construction of World Cup stadiums under the spotlight. In Singapore, it was the surge of COVID-19 cases among migrant workers in their dormitories in 2020 that highlighted their crowded, insanitary, and poorly ventilated living conditions. Such thermal inequities in Singapore and Doha unsurprisingly echoed those commonly found elsewhere in the global south, especially among the squatter and slum dwellers. While both Singapore and Doha are petropolises whose path to air conditioning dependency were entwined with their social energetic transition to greater reliance on vast quantities of fossil fuels, both are seeking to reduce their air conditioning addictions as they join the world in the seismic shift to a lower carbon future. To that end, the states and the sovereign wealth funds of Singapore and Qatar are investing heavily in novel cooling technologies and new spatial environmental configuration, especially for non-enclosed and outdoor spaces, turning themselves into vibrant sites of experimentations for possible thermal futures. For example, Singapore National Research Foundation and Sovereign Wealth Fund Temasek Holdings have directly or indirectly invested in research in various novel outdoor cooling technologies, like the radiative cooling prototype cool tube that you see in the middle, the solid-state cooler and bladeless fan Oasis, which is the abbreviation for outdoor active cooling in Singapore, that you see on the left, and the hybrid chill water and evaporative cooler Habitat that you see on the right. Qatar likewise has been test bedding new lower energy cooling technologies in its high-profile World Cup stadiums and Musharraf downtown Doha. As both Singapore and Doha are globally influential small states, these experiments are likely to be disseminated beyond their territorial boundaries to shape the thermoscapes of their region and beyond. To understand the heterogeneous thermoscape of Singapore and Doha, without segmenting them into discrete components, I developed the concept of thermal governance for the following analytical purposes. Firstly, the thermal in the concept is used as a connective thread that sees the various intensity of heat and the related problems of comfort and discomfort, health and illness as a continuous spectrum. It allows me to bring together the whole array of old and new techniques and technologies deployed to modulate heat under a single analytical framework. Though central, air conditioning is but one of the techniques and technologies that should be seen relationally. Furthermore, the thermal in the concept understands heat dynamically through the spatial connections of thermal exchanges across different scales, from bodies to interiors, buildings to cities, and nations to the planet. It also allows us to see heat and the mediation of heat through energetic conversions and related lines of bodily, urban, and planetary metabolism that interconvert thermal to other forms of energy and resources. Dealing with heat as a multidimensional and multi-scalar problem involves different and diverse technologies of mediation and energy conversion means that this paper has bring together scholarship from various disciplines. Such an interdisciplinary perspective is emphasized in the word governance of the concept, which suggests a departure from the prevailing technocentric and techno-determinist approaches of dealing with heat in the midst of a climate crisis, to understand the socio-technical configuration and technopolitics of regulating temperatures and metabolism of both humans and the more than humans. In underlying the socio-technical and technopolitical aspects of cooling, I situate technological artifacts and infrastructure of cooling within assemblages of political institution, socio-economic structure, environmental condition, ideologies, and knowledge and expertise that came together to form what Starosevsky calls thermal regimes. Central to thermal regimes are thermal power, which is, I quote, the enactment of social and political power through thermal manipulation, and as a pervasive means of biological, social, and environmental control. Singapore and Doha have been seen by political theories as post-colonial developmental and rental state respectively. The lingering influences of colonialism, the socio-political rationales of developmentalism, and the political and cultural economy of oil rent are the key factors that affect and are affected by the exercise of thermal governance. As an architectural historian and theorist, the focus of my account is on how thermal power is exercised with not just the assistance of cooling and heating technologies, but also as mediated by the built environment across different scales and as supported by various infrastructures of energy provision. In the following narrative of histories and of thermal governance in Singapore and Doha, I seek to account for these political influences while also re-articulating them through thermal spatial infrastructure conceptual framework. Thus bringing atmospheric and materialist perspective to these political theories. With that, let us move to the part 2 of the lecture. Singapore is known as an air-conditioned nation. The phrase was first used as a metaphor for Singapore's politics of comfort and control. But the label was later adopted by urban studies scholars because air conditioning was indeed ubiquitous in the small city state. The most visible changes of Singapore transition into air conditioning dependency were probably the many tall air-conditioned podium tower blocks erected in the city center from the 1960s to the 1970s, often built on sites consolidated from demolished shophouses and sold under the post-independent government sales of site program. These modernist towers were central to the urban renewal and territorial reconfiguration of Singapore. Conceived in the early 1960s, the podium tower blocks were envisioned as a part of modern spatial order that would displace the old, overcrowded and insanitary colonial shophouse city. Shophouses are terrace buildings originally planned with features like courtyards and louvered windows to facilitate quote-unquote passive cooling by keeping the sun out and allowing air circulation. But since the early 20th century, shophouses have been deemed as overcrowded and insanitary. By the mid-20th century, the living conditions in shophouses has further deteriorated and were regarded as slums ripe for demolition. Shophouses were porous not just environmentally, but also spatially, that blur the boundaries between the interior and the streets. As the name shophouse suggests, this were mixed-use neighborhood, combining commercial with residential spaces. The streets also took on multiple users as market, food center, and conduits for both pedestrian and vehicular traffic. During the mid-20th century, such spaces of interminglings were deemed disorderly, inefficient, and dirty that needed to be streamlined and cleansed. In contrast, the podium tower blocks were much larger, hermetically sealed buildings that created interiorized environment that rely on air conditioning to create a thermal steady state across time and space to keep their inhabitants comfortable. The boundaries with the exterior were also clearly demarcated and spaces were zoned for different functions for the purposes of order and efficiency. Many of the podium tower built were multi-use complexes, with the podiums housing arcades, shopping arcades, upon which sat towers of offices, hotels, and/or residences. Air conditioning transformed the interiors of the podium into what an advertisement called oasis of comfort for consumption. The air-conditioned interior allowed its socio-economic transaction to be unaffected by both the vagaries of weather and its diurnal and seasonal rhythms. The modernist podium tower from the 1960s and the 1970s were not very dissimilar to the North American precedents like the United Nations Secretariat Building and the Lever House. They might have lesser proportion of glass on their facades, and the glass curtain walls might be protected with sunshades, but they were planned on the same principles as the precedent and had similar massing and spatial configurations. This should not be surprising, as the typology was recommended by United Nations experts and often implemented by overseas trained Singaporean planners and architects familiar with the precedents. The podium towers were also built with imported technologies. For example, air conditioning components and even entire systems were brought from American and Japanese manufacturers like Carrier and Mitsubishi. And the envelopes of these buildings were assembled from various types of heat-absorbing and solar glass, again produced by major American and Japanese companies like Pilkington Glass and Nippon Glass. Does that then mean that air conditioning could be read as a universal technique, as Kenneth Franklin and others have claimed, and an air-conditioned built environment in Singapore is exactly the same as that elsewhere? Perhaps not, because of the entanglements with the post-colonial developmental states' technopolitical rationale that I'm going to go into now. Unlike North America, where the spread of air conditioning was primarily attributed to private capital, Singapore's transformation into an air-conditioned nation was often ascribed to the state, particularly the vision of its founding Prime Minister, the late Lee Kuan Yew. A Cambridge-educated Anglophone elite, Lee famously regarded air conditioning as the greatest invention of the 20th century. In justifying his unconventional choice, he said, I quote, "Air conditioning was a most important invention for us, perhaps one of the signal inventions of history. It changed the nature of civilization by making development possible in the tropics. Without air conditioning, you can only work well in the cool early morning hours or at dusk. The first thing I did upon becoming Prime Minister was to install air conditioner in buildings. Where the civil service worked, this was key to public efficiency." End quote. Implicit in what Lee said is the assumption that the hot and humid climate of Singapore diminished both physical and mental labor productivity and taught socio-economic development. And air conditioning was deemed by Lee as critical to overcoming the climatic barrier to efficient work and the attainment of quote-unquote civilization. This assumed correlation between hot climate and the lack of civilization was a common one among Anglophone colonial bourgeoisie. They were undoubtedly shaped by two constellations of powerful ideas from the 19th and 20th century. The first was the revival of the old Western construction of the tropics as a torrid zone and social environmental ardor to the temperate norm that was not only excessively hot and dangerously unhealthy for the white man, but also uncivilized and backward to Europe. 19th century miasmatic theory of disease transmission in particular attributed high mortality and morbidity rates in the tropics to these hot and humid climates. By the turn of the 20th century, as miasmatic theories were supplanted by germ theories, the causes for many tropical diseases became better understood and proper remedies and prophylaxis were found. As a result, the tropics was no longer deadly. But the perception of its discomfort continued, and its status as a negative authority persisted. The second constellation of ideas could be traced to the birth of thermodynamics in the 19th century. The two laws of thermodynamics on the conservation of energy and the irreversible dissipation of energy or entropy combined to emphasize the importance of energy conservation. The significance of the two laws were not just confined to the scientific world. Socially, they gave rise to what Kara New-Dajat called energy as the ruling idea, in which energy became a unit of equivalence, used to compare entities across time and space. It was most significantly used in the governance of work by evaluating, quantifying, and disciplining work according to energy-infused matrices of efficiency and productivity. Under the logic of energy, the human body turned into a machine for energy conversion and conservation. Fields of knowledge pertaining to the science of work, such as Taylorism, ergonomics, and industrial physiology, emerged from the 19th century to govern laboring bodies and non-human assemblages in work sites across Europe, North America, and their colonies. One of the main preoccupations in the science of work was human fatigue, as it affected production and output. Besides inadequate energy or the improper use of energy, fatigue was sometimes also attributed to the work environments of factories, where heat emitted and humidity created by machines and industrial processes were not properly dissipated, creating hot and steamy atmosphere. Such environment produced high heat stress that led not just to fatigue, but also affected the health of the worker and might even contribute to labor unrest. As such, these conditions were invested by, among others, industrial physiologists who put forward recommendations that included the use of technologies like electric fans and air conditioning to improve thermal condition and ameliorate work fatigue. While the enervating environments of high heat stress were limited to a few industrial sites in the temperate climates of Europe and North America, they were the inescapable and all-pervasive climatic conditions of the tropics. Some Europeans saw the tropical climate as energy draining, causing pathologies like tropical neurasthenia and tropical fatigue. Others, like Yale geographer Ellsworth Huntington, even went as far as deploying dubious, if not flawed methods to argue that climatic conditions affected the global distribution of human energy. with the hot climates leading to tropical inertia and manifesting in the lack of industry and civilizational attainment. These negative stereotypes of the hot tropical climates help to account for the colonial obsession with cooling technologies and techniques in the 19th and the first half of the 20th century. This ranged from the pith helmet to the punkah and the thermal antidote to the term antidote from the 19th century. With electrification from the turn of the 20th century, the technologies were extended to electric fans and air conditioning. Even before air conditioning came to Singapore, local newspapers were enthusiastically reporting its benefits, predicting how the technology would bring civilization to the tropics. The same assertion was, as we saw, repeated many years later by Lee in retrospect of air conditioning's role in Singapore's post-independent development. When air conditioning was finally introduced in colonial Singapore from the 1930s, its use was very limited, as an expensive technology to install and operate. Only a narrow spectrum of socio-economic elite in the colonial society could afford it at home and at work. In the beginning, air conditioning was selectively installed in limited spaces of consumptions like cinemas and hotels, where chill and dehumidified air became an integral part of the experience of consumption. In the post-war colonial period of the 1940s and 1950s, a number of key office buildings in Singapore pioneered having air conditioning integrated into their planning and design, alongside expensive finishes like imported rare stones and marbles as a mark of exclusivity and luxury. In other words, the cool, dry air of air conditioning was a thermal privilege that few enjoyed in colonial Singapore. Most of the colonized population still languished in the overcrowded, insanitary, derelict, hot, and poorly ventilated structures. With decolonization and the emergence of Singapore, first as a self-governing entity in 1959, and finally fully independent polity in 1965, thermal governance was significantly reconfigured. Unlike the colonial period, the prevalence of heat stress could no longer be accepted as an excuse for the underdevelopment of the tropics in the new era, when development was promoted internationally by governments, both capitalist and socialist, and institutions like the United Nations and innumerable other aid agencies. The climatic determinist theory by the light of Huntington was also turned into a climatic possibilist theory of control and modification. For example, British politician Sidney Frank Markham put forward the thesis that I quote, "One of the basic reasons for the rise of the nation in modern times is its control over climatic condition," end quote, through architectural, technological, and energetic intervention. This thesis of controlling rather than accepting existing climatic condition resonated with many and was used to advocate for the importance of climatic modifications through planning and design, so as to enable socio-economic development. Besides the will to develop, another impetus for climatic modification at that time was the acceptance of the freedom from heat stress and the associated fatigue, exhaustion, and injury as a part of universal human rights. Thermal comfort therefore became one of the basic criteria in the planning and design of buildings, particularly housing, in both the developed countries and the newly independent developing countries during the mid-20th century. Political scientists have labeled Singapore as a developmental state, one that is heavily interventionist through extensive planning and regulation to direct social development and promote economic growth. In Singapore, massive socio-economic programs were introduced in the post-independent period to stimulate export-oriented industrialization. These programs were reflected in the tabula rasa mode of development that led to a territorial revolution of the city-state. Unlike the colonial master plan that you see on the top left over here, that divided the nation into urban and rural, the post-independent concept plan that you see on the right treated the whole nation as a single integrated urban entity. Urban renewal and the erection of air-conditioned podium tower buildings in the city center were undertaken in conjunction with the building of satellite new towns and industrial estates in the outlying area. Residents displaced by slum and squatter clearances in the urban renewal were resettled in the public housing in the new towns. These new towns were planned to be self-sufficient with a whole array of amenities where state-subsidized housing, healthcare, education, recreation, and other social services were provided. Such developments can be regarded as an integral part of what has been characterized as productivist welfare capitalism, in which welfare provision was strategically targeted at promoting economic production and growth. The housing and amenities in the new town serve as what some scholars call wage subsidy, which ensure that many Singaporeans could attain a fairly high standard of living despite the relatively low wages in the 1960s and 70s. Furthermore, having to pay regular rent and mortgages also encouraged public housing residents to become disciplined wage laborers. Although not explicit, thermal comfort was central to the plan. Due to resource constraint, air conditioning was only one of the technologies used. While the podium tower blocks in the city center were air-conditioned, the majority of the other spaces were designed to minimize discomfort through passive design strategies. The public housing flats were planned and built as standardized types to save costs and enable rapid construction. One of the key considerations was the comfort of the inhabitants. Influenced by mid-20th century discourse of climatic design, the public housing flats were planned and designed to provide passive cooling for the comfort of their inhabitants. The early slab blocks were oriented such that the longer sides faced north or south, minimizing their exposure to solar radiation. In addition, access corridors were placed in front of the individual flats to further shade them from the sun. The layouts and the details of the flat were also designed to facilitate cross-ventilation. As the flats were occupied, the inhabitants' comfort were also augmented by electrical appliances like fans and refrigerators. Such features for passive cooling could also be found in the buildings housing the amenities in the new towns. These were later complemented by extensive urban thermal infrastructures that included trees and landscaping, void decks and covered walkways that provided shade from the sun and shelter from rain, and helped to connect both between buildings and new towns and between them and the other parts of the island, including the city center. From the above, I could say that there are at least two aspects to the post-independent reconfiguration of thermal governance in Singapore. Firstly, the thermal privilege of air conditioning was extended and made available to a much larger segment of the population through the podium tower blocks and complexes. Secondly, freedom from discomfort and undue heat stress, which were common during the colonial era, was also broadly avoided in the post-independent era through climatic design, especially through public housing and amenities in the new towns that 80% of the population eventually live in. Large-scale comfort infrastructure of covered walkways, landscaping, transportation also stitched the two thermal typologies together to constitute a variegated thermoscape for what I call a graduated thermal citizenship in a post-colonial developmental state. The post-independent reconfiguration of thermal governance in Singapore was enabled by a threefold expansion in electricity generation capacity from 184 megawatt in 1961 to 591.5 megawatt in 1971, and then another 11-fold increase to 2,106.5 megawatt in 1979. That was accompanied by a similarly exponential increase in electricity consumption from 636.6 gigawatt hour in 1961 to 2,269 gigawatt hour in 1971 and to 6,660 gigawatt hour in 1981, or 4 times in 1 decade and more than 10 times in 2. The expansion in electricity generation and consumption did not slow down even during the 2 oil shocks in the 1970s, just as its economy growth rate averaged between 8.7% from 1973 to 1979. This enormously undisrupted growth was possible because Singapore was an international oil center. In 1974, it was the world's third largest refining center after Houston and Rotterdam. In fact, Singapore was christened Houston of Asia, and its position as what Christopher Sellers called a petropolis helped tide Singapore over the first oil shock in 1973. The second oil shock in 1979 did lead to the introduction of certain energy-efficient regulation for buildings, but those were quickly forgotten during the mid-1980s, when economic restructuring and necessitated changes and when oil prices fell sharply. In the 1980s and 1990s, mega developments like Marina Square and Suntec City, with record-breaking chiller capacity of 10,800 and 20,500 refrigeration tons respectively to 8 cooling large encapsulated interiors were built. These two projects could be seen as initiating a trend of interior urbanism, organized around volumetric spaces such as large, dramatic, air-conditioned atria. In the 1990s, attempts were made for air conditioning to colonize outdoor spaces. At the Bugis Junction development, streets were covered with thin, single-glazed roof and air-conditioned. A proposal for the new downtown showed air-conditioned public spaces linking transportation nodes with commercial developments. Bus interchange were also enclosed and air-conditioned at around the same time, perhaps finally allowing one to truly travel in an air-conditioned bubble while using different modes of public transportation. Increased conditioning by mechanical cooling in the 1980s and 1990s Singapore, along with rising affluence, meant that more and more households in public housing began to install air conditioning appliances at home. The design of public housing evolved to accommodate air conditioning, first through the air conditioning hole in the 1970s and then the air conditioning latch in the late 1990s, when it was an integral part of the utility corner. The air conditioner has thus joined the kitchen, laundry space, and bathroom as an essential part of the house. Let us now move to the third part of the lecture, looking at Doha. Oil was discovered in Qatar in 1940 and exported from 1949. The economic activities generated by the extraction and export of oil and the revenue derived from oil fundamentally altered state-society relations, as oil revenue was used as a tool of statecraft. The oil economy caused the overall population of Doha to increase significantly from the 1950s. The urban area expanded to accommodate the increased population and greater economic activities. New districts such as Al Ashmaq were built during the 1950s. Houses in this new district follow the traditional Gulf regional typology of yard-oriented house, each of which has one or two simple single-story structure in a wall compound. The house of the elite will have structures that were sometimes two-story on 3 to 4 sides of the yard, forming courtyard houses. The largely windowless wall of these introverted houses define narrow, well-shaded lanes known as shikak. The forms of these yard-oriented and courtyard houses reflected the social and environmental conditions of the region. Their introverted configuration followed their inhabitants' emphasis on privacy. The thick walls of up to 0.6 meters of these houses provided a good thermal insulation from the hot climate. The incorporation of backjaw, which refer to both wind towers and air vents that channel air and facilitated ventilation, helped to cool the interior. And the presence of liwan or loggia in the structures created shaded areas within the houses. The new houses were, however, also built with new construction materials using concrete blocks for walls instead of traditional combination of limestone, mud, and gravels, and employing machine-cut timber for roof beams rather than mangrove wood of the past. Later, the expansion of the city was further accelerated by the construction of a new road system. The first of many ring roads that radiated from the old city was also completed by 1965. Likewise, the earliest of many suburbs that later constituted the car-dependent urban sprawl of Doha was also built around the same time. Besides housing and urban development, oil revenue also funded free universal education and healthcare for the Qataris. The first public school were built and opened from 1952. Free medical services were first made available in 1953, and a large hospital, the Rumaila General Hospital, was completed in 1957. Both the schools and the hospital were designed for passive cooling, just like much of the 1950s architecture in the region and around the world. Although the hospital was air-conditioned, it was planned and designed to be cooled by cross-ventilation in the case of air conditioning failure. The building's elevation was also covered with sunshades and verandas were positioned in front of the wards to minimize heat gain and prevent glare. Oil also fueled more directly urban metabolic transformation in electricity. Oil and later natural gas were used to generate electricity, which were heavily subsidized by the state and sold to Qatari at a price among the lowest in the world. This official beneficence contributed to a steep rise in electricity consumption from 480 megawatt hour in 1953, when electricity was first supplied as a public utility, to 157,835 megawatt hour in 1966, a whopping 328 times increase in 13 years. The steep rise could partly be accounted for by the widespread and excessive use of air conditioning, which already made up for more than 50% of peak electricity load in the mid-1960s. Water provision was similarly made feasible by the availability of abundant oil and oil revenues. Oil was used to power the energy-intensive method of obtaining potable water through seawater distillation. The first evaporator unit for seawater distillation was commissioned in Qatar in 1954, and by 1968, there were 3 units with a collective output of 1.5 million gallons of water a day that was supplied at heavily subsidized rate to the population. Despite the rapid expansion in the water supply infrastructure, the demand for water in Doha was projected to further increase by the 1970s, necessitating a further expansion of the infrastructure. The discovery and export of oil has thus turned what was a very scarce natural resource in one of the most arid regions in the world into one that was imagined to be abundant and unconstrained by the environment as long as oil flowed. Qatar's independence in 1971, coupled with 2 other related events, further accelerated the urban and infrastructural transformation. The first was the oil boom in the petroleum exporting countries during the 1970s, which coincided with the oil shocks in the West. The oil boom's crisis came about because of the embargo imposed by OPEC, whose members included many of the GCC countries. The 1970s was a decade that the oil-producing countries revoked the concession to international oil companies and nationalized oil production, which further increased the oil revenues from the already skyrocketing prices of oil. In Qatar, oil revenue increased from US 300 million in 1971 to US 2 billion in 1974, and further to US 5 billion in 1980. Among other things, this energy bounty fueled further rapid urbanization and created a construction boom in Doha. To regulate and order urban growth, a number of master plans were commissioned by the Qatari government. The first was produced in 1972 by the British architecture and planning firm Llewellyn Davis. It made 3 key recommendations, 2 of which intensified the urban processes that had already taken place in the 1960s. The first recommendation was to continue the renewal of the city center from the 1960s by proposing that the state acquire and clear more houses to free up land for development. Second, the master plan drawn up more extensive system of ring and radial roads from the city outwards to bring about further suburbanization. Third, it proposed land reclamation of a large area of salt marshes and tidal flats to the northeast of the city to create a new urban district. The first and second recommendation accelerated the ongoing oil-fuel suburbanization. Qataris received generous state compensation for their houses acquired by the state. And depending on their socio-economic status, they also obtained from the state free suburban housing or allocated plots along with interest-free loans to build their villas. The result was an en masse relocation of the Qatari population to the suburbs in the 1970s. The types of suburban housing that the Qataris relocated into varied to some extent and changed quite significantly in the few decades since public housing started in 1964. They started out relatively modest, but by the 1980s, the houses known as villas were quite large, with building footprints measuring anywhere from around 18 by 20 meters to double of that. The villas were planned in a manner that inverted the traditional yard-oriented house, with building placed in the middle of the compound, and the suburban plot in an island in a sea of freeways, roads, and residual spaces. These suburban villas were also related to the environment differently. Instead of thick walls with high thermal insulation, this villa had thin and poorly insulated concrete walls. They also did not have any of the passive cooling features found in the traditional houses. As such, the cooling of these suburban villas relied primarily on central air conditioning to keep their inhabitants comfortable. According to Sharon Noack, these villas were frequently too big and expensive to air condition without state-subsidized electricity for the Qataris. Together with the automobile dependency of suburbanization, these 1970s processes of urbanization and architectural production marked a shift towards lifestyle of even greater carbon intensity for the Qatari, made possible by heavily state-subsidized energy services. The third and final recommendation made by Llewellyn Davies was fully and swiftly implemented because land reclamation could create new land free from the complicated private ownership patterns of the existing land in Doha. Creating land through recommendation proved to be more economical than acquiring privately owned land. The area covered by the reclaimed land was named the New District and later became known as West Bay. The American architectural firm William L. Pereira and an associate was commissioned to plan the New District. His master plan of landscape mall, pedestrianized streets with plaza framed by office towers and high-rise housing was, however, not implemented. Only the complex that became the Doha Sheraton Hotel and Conference Center was built and completed in 1981, as it was regarded as a prestige project and was directly overseen by the Office of the Emir of Qatar. Taking the pyramidal form, the hotel was a large 13-story air-conditioned atrium that echoes similar atria enclosing climate control oases found in a number of other high-profile buildings in the oil-rich region at around the same time. As the first prominent building to be completed at West Bay, the Doha Sheraton Hotel and the Conference Center herald an era of energy-profligate high-rise commercial and office buildings that were subsequently erected at West Bay in the following decades. The rapid increase in the production of oil since the end of World War II happened alongside the internationalization of capital. The export of oil by the GCC region also led to the integration of the region into circuits of global capital. Two major political economic changes took place during the 1970s oil boom that shaped these circuits of global capital. The official withdrawal of Britain from the region led the United States to become the major foreign power, both politically and economically. The phased transition of the oil companies from foreign to local state control meant that the Gulf states became recipients of even greater amount of the oil revenues, which were known as petrodollars as they were denominated in United States dollars. These petrodollars were recycled in a number of ways. Besides being utilized in the global financial markets as loan and investment, they also used to pay for development assistance and technological transfer. This included architecture, urban, and infrastructure projects in the Gulf region that involved international consultants, machineries, building materials, much of which came from the United States. The architectural, urban, and infrastructure transformation in Doha discussed above and the attendant urban metabolic changes could be seen in relation to the circulation of hydrocarbons and thermal governance. First, the crude oil extracted from ground and the byproduct of natural gas produced changed the energy resource equation and were directly converted into energy services like electricity, desalinated water, transportation fuel, and air conditioning. Second, the crude oil extracted was also indirectly translated into petrodollars, which allowed the Qatari to redistribute these petrodollars as carbon-intensive form of welfare provision. The environment was also radically reconfigured with land reclamation, demolition, and construction, and air conditioning, alongside other forms of environmental engineering with intense amount of hydrocarbon-derived energy. As Toby Jones noted, one of the major sources of political authority and legitimacy of the regimes in the Gulf state stem from the ability to alter the old environmental imaginary of the desert and modify the torrid and arid landscape into one that is cool and lush, thus providing their population physical reliefs from the perils of desert life. Jones argued that in the region, the remaking of nature was a form of statecraft in which power over environment was also power over population. I finally come to the last portion. In this part, I'm going to be briefer as I try to make sense of the recent developments since 2000. The regimes of thermal governance described above have to be recalibrated as we entered this millennia. For Singapore, it was the climate crisis and the end of cheap oil that slowed, if not halted or reversed, the expansion of air-conditioned spaces that we witnessed in the 1980s and 1990s. Surge in prices of fossil fuels that were used to generate the electricity to power energy-intensive air conditioning meant that it is no longer economically feasible to mechanically cool large expanse of public spaces. Furthermore, on top of increasing carbon emission at a time when climate change mitigation measures is capping, air conditioning systems also produce waste heat that contributes to urban heat island effect that exacerbates the heat caused by rising temperature brought about by the climate crisis. Outdoor comfort became a great concern due to the urban heat island effect and rising temperature. The state response was to augment the heterogeneous thermal infrastructure. Among other things, the state planning agencies sought to expand the network of shaded and sheltered spaces by building more covered walkways. They also encouraged the erection of large canopies over open spaces to provide shaded and sheltered spaces between buildings, making them more comfortable and usable. In addition, novel cooling technologies like energy-efficient, high-volume, low-speed fans were installed, and many of these covered open spaces to create air movement and ventilate these large volumes. Singapore's planning agency also began to modify their landscaping policies and strategies to adapt to the needs of a densely developed city in the midst of the climate crisis. In 2001, they created Skyrise Greenery Initiative that initially became the program known as LUSH, Landscaping for Urban Spaces and High-Rises from 2009. The program encourages the creation of sky terraces, vertical greenery, and green roof. It also introduced planning instruments like the green plot ratio of ascertaining the amount of total greenery. Besides greening the city and increasing its biodiversity, the LUSH program also aimed at lowering the ambient outdoor temperature of the city and ameliorating the urban heat island effect. Besides state's thermal intervention also came in the form of investment in novel cooling technologies by state-linked enterprises. This included an investment in 2 startups making Vortex and Oasis, 2 different braidless fans using an augmented displacement ventilation system and solid-state technology respectively, by Temasek Foundation Ecosperity, which is part of the Sovereign Wealth Fund of Singapore. More prominent than the 2 braidless fans was the Habitat, a modified evaporative cooler by InnoSparks, a startup within ST Engineering that had the Temasek Holdings, the Sovereign Wealth Fund of Singapore, as the majority shareholder. Habitat was prominently deployed at the 2017 National Day Parade of Singapore, which could perhaps be read as a sign of the recalibration of thermal governance of the air-conditioned nation. Like Singapore, the state also played a central role in the reconfiguration of thermal governance in Qatar. Unlike Singapore, the spike in energy prices during the 2000s was obviously not a problem for Qatar. In fact, the huge surpluses from the period known as the second oil boom allowed Qatar and other GCC companies and governments to invest heavily to diversify their economies in face of risks posed to them by the climate crisis. Those risks were not just linked to rising temperature. They were also connected to the climate change mitigation strategies that might move the world away from the current high-carbon, fossil fuel-dependent economies. That will herald the end of fossil fuel, which would mean an existential crisis for states like Qatar that are almost entirely dependent on hydrocarbon revenues. One of the most prominent mega projects linked to the diversification initiative that came out of the second oil boom is the Musharraf downtown Doha. Owned by the state-linked entity Qatar Foundation, planned and designed by a group of transnational architecture and engineering consultants led by Arupt and AECOM, and located in Doha's Old Urban Center, Musharraf is a development that combines state-of-the-art sustainability technologies with inspiration drawn from pre-oil architecture typology and urban morphology of the region. Unlike the rest of modern Doha, it's a development made up of well-shaded, heavily insulated building in an urban fabric of narrow streets, small squares, and courtyards oriented to capture the cooling sea breeze. Partly opened recently, it is envisioned as a pedestrian-friendly development that provides environmentally comfortable outdoor public spaces that will draw people from the air-conditioned interior. To keep the users of these outdoor spaces comfortable, the design consultant combined the passive means of cooling using the urban fabric and architectural features with novel, low-energy active means that include radiant cooling and soft conditioning. The projects represent both an attempt at reducing, if not reversing, the urban sprawl of Doha and moving away from the Qatari norm of building primarily inappropriate and energy-profligate architecture. Located below Musharraf is one of the world's largest metro stations and the hub of Doha metro system, where 3 different metro lines intersect and where football fans are expected to change train to move between the different stadiums housing the 2022 FIFA World Cup. These World Cup stadiums are probably the most high-profile and controversially so sustainable projects in Qatar beside Musharraf. Among the World Cup stadiums completed so far are those shown on the screen. As an integral part of what has been promoted as the first carbon-neutral FIFA World Cup, these stadiums were designed and built to be resource efficient and were certified as such by Green Assessment System. In terms of thermal control, these stadiums are like the buildings at Musharraf in that they combine passive design features with a specially designed air conditioning system for the large semi-outdoor spaces. The air conditioning system includes small under-seat vents that discharge cold air to keep the spectators comfortable with large pitch-side diffuser that cool the footballers on the playing field and help them avoid potential heat injuries that Qatar's summer high temperature might inflict. Although the 2022 FIFA World Cup has moved to winter due to concerns with Qatar's sweltering summer heat, the Qatar World Cup Organizing Committee continued with their plans to install air conditioning system for the stadium. Dr. Saud Abdul Ghani, the Sudan-born Qatar University engineering professor who was behind the implementation of the air conditioning technology, described the stadium as, quotes, microclimate control bubbles, unquote. Now that we have an overview, I would like to end not with a conclusion, but with 3 sets of questions relating to thermal governance. The first is on equity. We discussed the thermal governance in Singapore and Doha in relation to graduated thermal citizenship and thermal privilege. For Singapore, graduated thermal citizenship means that all citizens are promised freedom from heat stress and some level of comfort that are commensurate with the improvements in material conditions that come with economic growth. That was a promise of the developmental state and also the social compact. For Doha, thermal privilege means that a small population benefits from hydrocarbon services and revenues that is distributed by the state. Both promises of thermal comfort has come under stress in recent years, but both states seem to manage quite well. But that is only if we omit the migrant workers from our consideration. We have briefly alluded to the exclusion of migrant workers, especially those low-wage, low-skill migrant workers. What is the rationale of inclusion and exclusion? Is it based on belonging in terms of nationality, ethnicity, and religion? Or is it based on economic capacity to afford something? When do this intersect? Speaking of economic capacity brings us to our second point, capitalism. Thermal governance was calibrated in the developmental state of Singapore to attract foreign investment, improve productivity, and promote economic growth in the early post-independent days. In Qatar, thermal governance was a form of redistributing hydrocarbon revenues as an oil welfare state. More recently, innovation in cooling technologies and new modes of thermal governance was seen as a worthwhile investment that could reap economic benefits, as the market for cooling technology is supposedly overdue for disruption, as the British millionaire Richard Branson noted recently. How could one further articulate this relationship between thermal power and capitalism? And finally, carbon is closely linked to the question of comfort, or at least our current form of comfort is one that is carbon intensive. In his influential book, Timothy Mitchell encouraged us to follow the carbon and understood how carbon is transformed from one form of power to another as it circulates, particularly calorific power to socio-political power. He even argues that cheap oil in the post-war era allowed the construction of the economy that can grow without limit. But he has much less to offer in terms of how the built environment mediates the circulation and conversion of oil and power. This is perhaps where urban metabolism can come in and help us understand how resources and energy were channeled through buildings. Buildings, as we all know, are not just conduits in which operational energy flow, directly affecting carbon emission. They were also physical structure of embodied energy and carbon. How do we follow the carbon through the built environment using the idea of urban metabolism? With that, I thank you. Thank you very much for your patience and for allowing me to share this research. Thank you.
Thank you. Thank you so much, Jiat-Hwee, for this extremely rich and dense lecture. I'm always very impressed and fascinated by your work and how you evolve at the intersection of our architectural history, science and technology studies, and environmental humanities. And this is a very good example of the renewed histories that we are trying to put at the fore of our discipline, of our field. I would have myself a few questions or remarks, but I prefer to let the audience ask questions if anyone has some in English directly or in French, and I can try to translate. So no question for now. Maybe people are a bit shy, but I don't know if there are really questions or remarks, but and it's more at the core of your work is extremely rich and solid. I have more questions at the, let's say, border of your work or interrogations. One is, do you link air conditioning, your study of air conditioning, with glazing and insulation, which is really part of the way air conditioning works, of course, and I mean the whole envelope of the building, but glazing and insulation in particular. Do you consider what we could call a thermal system or a thermal complex, which would tie air conditioning and the envelope and insulation and glazing?
Yeah, thanks, Paul, for asking a very interesting question on the materiality of air conditioning system. Yeah, this is something that I think colleagues like Thomas Leslie, for example, has looked into in the case of North America. So he says something that's quite interesting. So the curtain wall system, of course, there's a lot of innovation in glass, especially in solar glass and in heat rejection glass, and also in double glazing. And the other thing that he mentioned that is very important to air conditioning is really fluorescent light system, because fluorescent light emits a lot less heat. So that also managed to reduce the heat load that make it a lot more manageable for air conditioning system. So I think he looked at the dynamics between the envelope system and the innovation in glass technology, the change in the fluorescent lighting technology as well, particularly from incandescent light. And then he talked about how this two relate to air conditioning. My interest is also in that, but in Singapore's case, I don't think there's a lot of innovation. It's a lot more about importing similar system from Japan and also from the US. So a lot of the heat rejection glass and solar glass that I look at, they were actually manufactured in Japan. So I'm pretty interested in that. But the other thing that I'm even more interested in is when air conditioning is not like an installation, is not designed together with the building as a system, but when it becomes installed as an appliance, for example, in the public housing. So when it's installed as an appliance, it's essentially taking what was originally not designed for air conditioning, but designed for passive cooling, and then how subsequently the installation of air conditioning then changed the interior and change also the kind of everyday practices in interesting way. So I didn't have time to show that, but what I did is to show that over the decades, how the public housing, the design changed a little bit because they had to accommodate the split system. So the split system has an outdoor condensing unit and then the indoor, air handling units. So that changed a little bit. But what changed a lot is what is normally think of as the kind of normal interior furnishing for HDB flats. So at the beginning, when they don't have air conditioning, it was very much about porosity. And the furniture used was also a lot lighter weight. The upholstery and the cushioning was a lot thinner. But subsequently, when air conditioning became very, very common, the type of furniture changed. And what is interesting is that in Singapore now, if you go to IKEA, you can buy duvet. Even though, we are very hot, but you can buy duvet, and there are like 3 to 4 types of duvet sold by IKEA, depending on how cold your interior is. So you could begin to see a kind of a new thermal material culture that comes from the installation of air conditioning. Yeah, so I thought that for me is probably the more interesting part of the kind of, it's a bit like a social life of technology, a social life of the social life, and also the thermal material culture that is resulted from technological changes. Yeah, so I find that a bit more fascinating. Yeah, partly because that I think is something that maybe not that many people has written about, whereas the air conditioning system and the envelopes and the lighting system, for example, I think Thomas Leslie has really done fantastic work. Yeah. So okay. I don't know, that's a long answer to a very short question.
No, very, very, very interesting answer. Thank you. I have maybe a related question as another way to maybe extend your work, which would be to look at the history of the industry of air conditioning and of unit air conditioning system. It's extremely striking when you walk in the streets. The whole landscapes of entire cities are marked nowadays by these units, air conditioning units on facades. And are you interested in the history of this economic sector? Like you showed us the growth of electric production and consumptions with very precise figures. Are you also interested in this part of the topics, like the industry of these air conditioning units, or is it another side, another topic?
Paul, I'm interested. The main challenge is to find interesting narratives and story to tell. So I think the connection with the larger infrastructure is a very interesting question. I have not done enough work on the electricity infrastructure yet. I'm very interested in that because I'm interested to understand what does it mean to think of air conditioning from the larger urban infrastructural scale. So right now, what I'm trying to look at is this thing called district cooling. It's a bit like the district heating in many Europeans and many different parts of the world. But in recent years, Singapore and also the Middle East has been promoting district cooling. So I'm quite interested in the intricacy of district cooling, but I'm not sure what is the analytical angle that will make it very interesting. So this is something that I'm still researching. Yeah, but this district cooling is certainly quite big, quite important, in part because it's deemed as a more energy efficient system. And it also has got a certain kind of advantages compared to traditional air conditioning. So for example, individual building can just tap into a chill water network. So they do not need to have cooling tower. So apparently there are all kinds of advantages of things like that. But I'm trying to think of an interesting analytical angle to talk about that. And that is something that I have not found yet. Yeah. So recently there are a few books that are quite interesting. There's a book that talks about the Osaka Expo in 1970. So apparently that was one of the first very big district cooling system that was installed in Asia. And there's a reason for that. It was an attempt to create a city that can be computerized, whereby everything can be centrally managed in terms of not just flow of electricity and the provision of comfort, but also the movement of people. So there is a kind of a vision of that kind. So I'm interested to think about the politics of this kind of centralized control. I'm interested to think about the kind of centralized infrastructure versus the decentralized one that I showed earlier, which is this patchwork of shelter walkway and the large sheds and urban greenery, because that is a bit more ad hoc. That is really based on a certain set of policy and policy incentive, and is very often a private investor or real estate companies will put in money. So of course that set of relationship is quite different from something that is designed centrally as an integrated system. So infrastructure is something that I'm still thinking about. I mean, currently the book is going everywhere. There's something on infrastructure, there's something on materiality, there's something on air conditioning history. So I'm not sure how to bring everything together yet, which is why the lecture is also going everywhere in a way.
No, it looks very structured and very, very solid. And we have thank you. We have a question in the chat by Alexandre Milnicek. Je ne sais pas si je prononce bien. I'm going to read it. Thank you for your presentation. What do you think about recent decision of Italy, which decided to limit air condition to 25 Celsius degrees during summer and 19 Celsius degrees heating during winter to limit fossil energy consumption? Would it be something that could or should spread across countries?
Yeah, so thanks for the question, Alexandra. So I think this is something that a number of countries has already done in relation. This is adjusting the thermostats and changing the norms is something that many countries have already now done. And recently, I'm not sure whether you're aware, in North America in particular, there are this thing called the thermostat wars between genders, between the male and the female. So the recommended thermostat setting for comfort is 22 degrees Celsius. By right, that is the ISO standard and also the ASHRAE standard. But that standard was based on a calculation and experiment done in the 1970s. In the 1970s, a typical office worker at that time was a 40-year-old man wearing a three-piece suit. And a 40-year-old man has very different metabolic rate from a woman or from a younger woman especially. Today, the typical office worker is someone in the late 20s, I think, at least in North America. So the thermostat comfort for a 40-year-old man is now becoming an environment that's becoming too cold for the average worker office worker in North America. So when a Dutch, I think, researcher published a paper saying that, you know, the calculation is based on the wrong assumption and an outdated assumption, there are a lot of outcry, and all the major media outlets all reported on it, and they call it a thermostat war. And it also become these things between the far right and the liberal people. So that's a weird thing. But anyway, I digress. I say that in recent years, in order to cut down on electricity consumption and carbon emission, many countries have recommended new thermostat settings. So I think Italy is one of those, but I think different parts of the world, there are also new recommendations. But what is probably more interesting is not just adjusting the thermostat. The Japanese started this thing called the cool beast, which is that in summer, they will wear summer dress to office. So, you know, the Japanese workers tend to wear pretty formally, kind of a suit, tie and suit. And then, but I think in the 2000s, they started this thing called the cool beast, whereby in summer, they will all start to wear short sleeve shirt and loose fitting shirt to the office. And also, supposedly they encourage their workers to wear Bermudas as well. But Bermudas, I think, probably didn't take on that well, but short sleeve shirt became quite common. What is quite interesting about that is two types of adjustment, not just adjusting the thermostat, but also adjusting what we wear, so that one can feel a lot more comfortable at a much higher temperature setting. So perhaps I think that interaction between thermostat setting and attire and maybe some form of social practices is pretty important. And also in recent years, there's a new thermal comfort standard that is called the adaptive thermal comfort standard. And these are based on experiments not done in the laboratory, but based on field results. So this group of people have also recommended different kind of thermostat settings for comfort zone. So there's quite a lot of work going in this area. Yeah, so I think you're absolutely right to point out about ways to rethink the thermostat setting. Yeah.
Okay, thank you. We had another question in the chat, but it's already answered, apparently. Yes. Are there any other questions? If not, I would have maybe one more of a remark again, I think, about maybe a philosophical approach aspect of your work. Are you interested in the idea that matter, and especially oil, is converted into immaterial, if not invisible, an invisible thing, namely coolness? And that in this process, there's what some authors call a process of invisibilization, like something very visible materials that we can see that as a waste become like immaterial, and as it had no effect on our built and natural environment. And one of our colleagues, Fanny Lopez, speak about this invisibilization when she makes the history of large technical system like nuclear power plants or oil or gas power plants are produce electricity that is then used in buildings, and the users, the inhabitants, people in general, don't have access to the visible and material consequences of their choice. Do you use, or do you reflect on this concept of invisibilization? If it's clear.
Yeah, Paul, that's really interesting. I think there's definitely at least two aspects to the invisibilization in relation to air conditioning. The first part is what you call, in Fanny Lopez terms, the kind of a large technical system. infrastructure in itself, infra means something that is under, right? So infrastructure tends to be invisible. That's why, you know, there are people who talk about air conditioning and environmental system as air conditioning as separating the interior from the exterior. That is only true to some extent, but very often it is actually not separated. It's just connected in ways that are invisible. So connected, for example, through the need to have electricity network, for example, to power the air conditioning, or the other is the pumping out of the waste heat from the air conditioning system to the outside, creating urban heat island effect. So that is one level of invisibilization. The second level of invisibilization in air conditioning got to do with the properties of air in itself. So, you know, Peter Sloterdijk, the German philosopher in recent years, has been very famous. One of those things he talked a lot about is how in recent years, there has been explication of air, something from the background to become something to the foreground. And he talked about that in terms of how air was, chemical weapon was first used in the First World War, whereby I think the German army used it in Belgium. And he talked about how suddenly when what you typically take for granted, which is the air you breathe, suddenly become poisonous. And then you realize that that affected lives. So one can no longer take the kind of ambient surrounding as taken for granted anymore. So in recent years, there's quite a bit of interest in the atmosphere, in air, and in kind of atmospheric politics. Yeah. And I think air conditioning and it is not exactly about poisonous gas. It's not exactly about life and death, even though that might change with rising temperature. But it's very much about a kind of an invisible ambient environment that condition our body that we sometimes take for granted as well. So I thought there is something there that can be quite interesting in terms of thermal exchanges, in terms of thinking about atmospheric politics and the ambient. Yeah. So one part of what I'm trying to do is to really to think about it and to maybe establish the relationship between how energy is used to chill air and how then it convert to some kind of a thermal power. Yeah. So that is the kind of ambition that I hope to make it a bit clearer. Yeah. So yes. Now you can understand why the book is going everywhere, right? Because there are these attempts to do so many things here.
No, but it's you have two case studies. It's extremely clear and conceptually also very clear. Another question by Alessandra Miglio. Do you use the concept of low-tech in your research? This concept is becoming popular in France in the context of the Anthropocene, but I don't know if it has been if it's used in Singapore and in the rest of the world.
Yeah, no, I didn't really think about question of high tech and low tech. I can imagine why low tech is now becoming popular. And I think the question here is maybe less, if I may say, is less about whether it's high tech or low tech, but rather whether is it an appropriate technology. I think what makes an appropriate technology is really an interesting question. How can we achieve certain kind of outcomes using the most appropriate means? Yeah, I think this is where I think air conditioning encounter a lot of problems. But unfortunately in Singapore, there's a lot of discussion about high tech, partly because there's in recent years, I showed that global cooling price. One of the sponsors for the global cooling price that I showed early on is Richard Branson, that British billionaire. So Richard Branson, as an entrepreneur, he come into cooling technology, and then he said that because there's very little innovation in air conditioning. So they have a figure about how much the efficiency of the air conditioning system has improved over the past maybe 50 years. And he said that it's actually very low. So he said that it is an industry that is ripe for disruption. So there's a lot of interest in disrupting air conditioning industry. And a lot of the disruption comes in terms of thinking of novel cooling technology. So there are things like thermoelectric cooling technology. I'm not sure whether you have seen those. Think about something, a watch or something that you can wear, and then it uses electric to cool a surface, and then it transmits to a pulse at certain part of your body, and supposedly will stimulate a cold movement. So it's new disruptive technologies like that has been tried out. And there's also a lot of interesting combination between a traditional evaporative cooler together with kind of other systems. So there are a lot of experiments in hybrid system and also in smart technology. So now probably one of the big thing is smart thermostat. I think in terms of heating, you have the Nest thermostat, which is very big, under Google, and now it's very big around the world. So there's a lot of new high-tech, disruptive tech and smart tech. I don't think there's enough discussion in low-tech. Maybe because there's not that much money to be made in low tech, so that is my suspicion. Yeah, I mean, but I think a lot of things can be easily done. For example, certain traditional way of fending or of keeping the space cool might actually still be relevant today. Yeah.
Okay. Thank you, Jiat-Hwee and Alessandra, for this question. I'm afraid we are running out of time, so we are going to stop here. So thank you, really, Jiat-Hwee, for this lecture. It's always very rich and inspiring for us as scholars and as students, I hope. And we will meet again in 2 or 3 weeks from now on May the 17th for the last lectures. My lecture, and yes, so thank you everyone. Thank you, Jiat-Hwee.
Thank you, Paul, and thank you everyone. Thank you for having me. It's a real pleasure to be here. Thank you. Goodbye. Take care.
Thank you. Bye.